Okay, so in this chapter, we will be discussing about the plate tectonics theory. So why do we need to study plate tectonics theory? So we experience different geologic activities for how many years? Not just in our place, but also to other places in the world. We experience volcanic eruptions, earthquake, and other geologic activities. And this plate tectonics theory will explain to us what mechanism that drive these geologic activities.
It happens because hot rock rises, heated by the Earth's core.
Before we proceed to plate tectonics theory, let us discuss first these two existing theories, which explain the different geologic activities on Earth. So we have the Continental Drift theory and the seafloor spreading theory. So what is the difference between these two? So according to Continental Drift theory, there was a single supercontinent known as Pangaea that was drifted away 200 million years ago. That was proposed by Alfred Lothar Wegener. So Wegener was convinced that all of Earth's continents were once part of an enormous single landmass known as Pangaea. Pan means large and Gaea means land or earth. So Pangaea means all lands. So 20 million years ago, Pangaea was, there was a single supercontinent known as Pangaea that drifted away. Then next, you have theory by Harry Hess. We have the seafloor spreading theory. So in this process, molten rocks rises from within the earth and adds new seafloor, known as the oceanic crust, to the edges of the old. So seafloor spreading is most dynamic along giant underwater mountain ranges known as mid-ocean ridges. So as the seafloor grows wider, the continents on the opposite sides of the ridge move away from each other. So as there will be a new formation of a new seafloor, or as new seafloor grows or grows wider, the continents of the opposite edges move away from each other, causing the continent to drift away. So this seafloor spreading theory, an example of this was the North American and Eurasian tectonic plate, for example, are separated by the mid-Atlantic ridge. So these were two existing theory that explain the movement of the Earth's structure or the Earth's landform. So, but why these theories are not fully accepted by scientists? So they lack evidences on why, or they lack evidences that drive this mechanism to move, or that drive this geologic activities to happen. So they lack evidences. So according to Continental Drift theory, so the first proposed by Alfred Lothar Wegener is that it is called as the Ur continent. Ur means first or original, continent means continent. So from his native German language. So Pangaea, which means all lands in Greek. So scientists do not accept Wegener's theory of continental drift. One of these elements is lacking. What's the mechanism for how it works? Why do the continents drift and what patterns did they follow? So Wegener suggested that perhaps the rotation of the Earth caused the continents to shift towards and apart from each other, but it doesn't. So the idea of Alfred Lothar Wegener was not fully accepted during those times since he lacked evidences. And why the supercontinent moved or drifted away. That is why scientists developed another theory, which is known as the plate tectonics theory. So plate tectonics theory is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movements. So the theory, which solidified in the 1960s, transformed the Earth sciences by explaining many phenomena, including mountain building events, volcanoes, and earthquakes. And also, it also revolutionized the earth sciences by explaining the movement of geologic plates that causes mountain building, volcanoes, and earthquakes. So according to plate tectonics theory, the Earth's outermost layer or lithosphere, made up of crust and the upper mantle, is broken into large rocky plates called as tectonic plates or lithospheric plates. So from the Greek word tectonikos, which means built. So the Earth is made up of very large rigid units of rocks called as tectonic plates, plates or lithospheric plates. And also, according to plate tectonics theory, these plates are also moving continuously in order of 2 to 15 centimeters per year. So these plates lie on top of a partially molten layer of rock called as the asthenosphere. So the asthenosphere from the Greek word asthenes, which means weak. So these plates are continuously moving, but in a very small motion lang. So for in order of 2 to 15 centimeters. So the interaction of tectonic plates is responsible for many different geological formations, such as these landforms, the Himalayas, the East African Rift, and the San Andreas Fault in California, USA. So large-scale geologic activities happens on near or occur on plate boundaries. Also, areas farther from plate boundaries are less prone to geologic activity. So remember, kapag malapit ang isang lugar sa tectonic plates or sa plate boundaries, most likely they experience large-scale geologic activities. And kapag malayo naman ang lugar doon, or if the location of the place is farther from the plate boundaries, they can still experience geologic activities, but lesser only. So remember that the Earth is made up of plates, tectonic plates. So take note of the 7 major plates on Earth. So we have the Pacific Plate, the Antarctic Plate, the North American Plate, the South American Plate, the African Plate, the Australian Plate, the Eurasian Plate. So other plates are known as microplates or the minor plates. So these 7 major plates are the 7 major plates on Earth. So these plates are continuously moving in different direction. So, and according to plate tectonics theory, plates or locations that are found on near plate boundaries, so these are the plate boundaries, experience large-scale geologic activity. So when the location of the place is on or is on the plate boundaries or near the plate boundaries, they experience more geologic activities such as earthquakes and volcanic eruptions. So look at this example. So these are different histories of the earthquakes and volcanic eruptions. So these are the these are the plate boundaries. So look at the Philippines. So Philippines is located along the plate boundaries. So it experiences stronger earthquakes and other geologic activities. And according to plate tectonics theory, places that are farther from geologic that are farther from these plate boundaries experience less. Hindi sila masabi na hindi sila experience, but they experience lesser geologic activities like earthquakes and volcanic eruptions since malayo sila doon sa plate boundaries. So since dito mas exclusive ang mga earthquakes and volcanic eruptions along this area, so malayo sila, they can still experience but lesser degree na lang. So that is plate tectonics. And with that, they lay down different evidences of Wegener's idea and the plate tectonics theory that we are using today. So according to Alfred Lothar Wegener, so the eastern coastline of South America and the western coastline of Africa seem to fit snugly into each other. So, yung kay Wegener na idea, yung South America lang and the South America and the western coast of Africa seem to fit. Doon lang na area. But in the science today, in the plate tectonics that we are using today, the shapes of several continents seem to fit into each other. So most of the continents, kapag pagsama-samahin, they can fit together just like with the jigsaw puzzle. Then, in Wegener's idea, similar fossils of plants and animals were found in the eastern coast of South America and the western coast of some parts of South America and the south of the African continent. So, in the recent evidences, rock types and fossils in South America and South Africa are very similar in terms of their sequence and age. Animals in South America share common ancestor with those in Africa. And also another evidence is, according to Wegener's idea, there are other cases wherein cases of similar fossil sequences from land masses of the eastern and western coast of other oceans. So in the recent theory, mountain ranges of different continents are made of the same rocks, form in the same sequence and are of the same age, but are now far from each other. Sequence of rock layers on the opposite side of oceans match each other. So geologic studies of areas with glaciers in the eastern South America match those in South and West Africa. And also fossils of tropical plants were also found in Arctic and Antarctica. Okay, some of these fossils are this. So we have the reptiles, Sinognathus. We have also the freshwater reptile, the Mesosaurus. The Mesosaurus is found in South America and Africa. And Sinognathus is found in the continents of South America and Africa. The Lysosaurus is found in 3 areas of Antarctica, India, and Africa, while the fossil of plant Glossopteris is found in Africa, Antarctica, South America, and Australia. So these are the fossil evidences of plate movements. So paano makatravel ang Sinognathus na reptile ito na ang layo-layo ng South America sa Africa. So the Sinognathus should travel South America to Africa. But the fossil was found in both continents. So it's a big possibility that this South America was once joined with Africa. So that is how plate tectonics theory is. So with that, this question, are the volcanoes and earthquakes scattered randomly on Earth? So the answer will be no. Earthquakes and volcanoes are not randomly distributed on Earth, but occur primarily where? They occur along the limited zones of the plate boundaries. Doon talaga sila most prevalent sa plate boundaries. So with the understanding of plate tectonics, scientists recognize that these belts occur along plate boundaries. So as what we have said earlier, areas along the plate boundaries experience stronger or large-scale geologic activities. On the other hand, areas farther from those plate boundaries or along tectonic plates away from that area experience less geologic activities. Same with this, you have also learned in your grade about the Pacific Ring of Fire or the Circum-Pacific Belt. So Circum-Pacific Belt or the Pacific Ring of Fire is a long line of volcanoes around the Pacific Ocean. So make up the famous Ring of Fire. So this Ring of Fire is made up of active and dormant volcanoes on Earth. So these are made up of 452 volcanoes. So the one of its prominent volcano in the Philippines is the Pinatubo, the Mayon, and Taal. In Japan, we have Sendai and Fuji. In Washington, we have Mount St. Helens. In Mexico, we have Paricutin. In New Zealand, we have Christchurch. Peru, we have Achille. We have Santiago. So these are the different places and their respective volcanoes found along the Pacific Ring of Fire. So the majority of Earth's volcanoes and earthquakes takes place along the Ring of Fire. So the Ring of Fire accounts 452 volcanoes and is home to over 75% of the world's active and dormant volcanoes. So where in the world do earthquakes occur? So that's what I have said earlier. Since the Earth is made up of tectonic plates, so these plates are continuously moving. Since it is lying on the weaker portion of the Earth, the weaker layer of the Earth, which is the asthenosphere. So earthquake is a sudden movement of the Earth's crust that may result in the formation of new landform. So this is an earthquake which we have experienced last week lang. So when we say fault, this is a break on the Earth's crust wherein the earthquakes occur. The epicenter is the point directly above the focus of an earthquake. And the focus is the origin or the actual location of the earthquake. Again, the fault is the break. Focus is the location of the earthquake, the actual location. And the epicenter is what? The epicenter is the point directly above the focus of the, which is the origin. So how does epicenter can be determined? So it is determined by the instrument seismograph. And they need how many stations to get the epicenter? So it needs three seismic stations to determine the epicenter of the earthquake. That method is called as triangulation. So take note of that. 3 seismic stations to determine the epicenter of the earthquake, known as triangulation. So fault is the break on the ground along which movement has taken place. So how this fault moves? So first we have, it moves in a strike-slip motion, which happens in a transformed plate boundaries. Then next we have the normal. So the hanging wall moves down. When we say hanging wall is the one that moves during an earthquake, the portion that moves during an earthquake. And we have the thrust or the reverse fault. The hanging wall moves up. So we will later in this part we will explain what are these transform boundaries, divergent and convergent boundaries. So these are the different three, ways on how this fault move. So trenches. So trenches are like deep canals on the seafloor. So the world's deepest trench in the world are the Marianas Trench. Is the Marianas Trench. So its depth is 10 kilometers, greater than the height of Mount Everest. In the Philippines, the deepest trench is called the Philippine Deep. So why are we talking about trenches? So that is because sudden movements of the seafloor at the trenches also generate earthquakes. So the Philippines have also different trenches. So it also accounts because trenches also bring sudden movements on the seafloor. So when these trenches move on the seafloor, this also generate earthquakes. So location of the earthquake epicenter around the world. So look at this one. So what we have said, are earthquake epicenter randomly distributed on Earth? The answer will be no, since earthquake epicenter are most located along the plate boundaries or along tectonic plates. So that is for the plate tectonics. Let us now then discuss the Earth's structure. So as we all know that the Earth is one of the most amazing planet in the entire solar system. So the Earth, the shape of the Earth is oblate spheroid, meaning the diameter at the poles is approximately less than 70 kilometers than the equator. So it is not sphere in shape, but oblate spheroid. So four spheres of the Earth, that we have the lithosphere, solid, also known as geosphere, hydrosphere, the water sphere, atmosphere, gas, and biosphere, the life sphere. So these four spheres are interacting with one another. That's according to Gaia hypothesis, that without one, life on Earth will, the life on Earth will not happen. So crust. So the crust is the outermost layer of the Earth, where all organisms live, made up of the continents in the ocean floor. So it is made up of the oceanic and continental crust. So most abundant element, we have oxygen and silicon. So remember that oceanic crust is denser than continental crust. So mantle, thickest layer of the Earth. So that's 2,900 kilometers thick, made up of hot molten rock called magma. So study shows that mantle is divided into two layers, the upper and the lower mantle. So the mantle is also composed of these two portions. We have the lithosphere, topmost sublayer. So Greek word lithos, which means rock. So it is composed of brittle, cooler layer of rock around 100 kilometers in thickness. On the other hand, asthenosphere from the Greek word asthenes, which means weak. So it means weak. So it helps in the movement of the lithosphere. The next layer, we have the outer core. So the outer core is 2,300 kilometers thick, made up of molten liquid iron and nickel with sulfur and oxygen, maintaining its liquid property. So scientists believe that this layer induces the Earth's magnetic field. Then we have also the inner core. So the inner core is the innermost layer of the Earth, made up of solid iron and nickel, and the temperature ranges from 5,000 to 7,000 degrees Celsius, which is hotter than the surface of the sun. That is how our structures are the different layers of the Earth. So we have the crust, the mantle, the outer core, and the inner core. But in between these layers are boundaries. So we have The boundary between the crust and the mantle is called as the Moho-Rovissic discontinuity, or also known as Moho. The boundary between the between the mantle and the outer core is known as the Gothenburg discontinuity. And between the outer core and the inner core is the Lehmann discontinuity. So this boundary separates one layer to another structure. And you have also done or finished this activity. So plate movements. I hope you have submitted already your outputs. So I will discuss your activity now. So in your activity, it is it is presented that plates move in three major directions. So first, we have the convergent plate movement. So when we say convergent plate movement, two plates collide or move toward each other. And we have three types of convergent plate movements. We have oceanic convergence, oceanic continental, continental. Remember, I have discussed earlier, we have types of crust. We have the oceanic and the continental crust. And convergent plate movement is moving in, and we have three types of convergent plate movements. So when we say continental and continental, when two continental plates converge, what will form? We have the mountain range, mountain ranges. An example of this is the Andes mountain range, the Andes mountain ranges. So the longest mountain range found in South America. So that is continental convergence. Next, we have oceanic continental. So when we say oceanic continental, when oceanic continental converge with each other, what structure will be formed? So it will form trench, which is the deepest portion of the bodies of water, and volcanic arc. Take note of this. When ocean and continental convergence occur, it will form the structure trench. So it is like a deep canal on the ocean or sea. Then also the volcanic arc. So what happens during oceanic continental convergence? So there is a so-called as subduction zone wherein one plate subducts over the other. Ito yon. In this case, when oceanic and continental converge with one another, since the oceanic is denser than the continental, the oceanic most likely to subduct over the continental crust since mas mabigat ang oceanic, or denser ang oceanic crust kaysa sa continental crust. That is why trench and volcanic arc will occur during this type of convergence. And the last type of convergent is the oceanic. So when this happens, another structure will form. We have the trench or the deep sea canal or canal-like structures on the bodies of water like ocean and sea. It will also form island arc. Island arc, yung kanina, volcanic arc sa oceanic continental. So that is convergent plate movement. Two plates move towards each other. Divergent plate movement, also known as spreading boundaries. So two plates move away from each other. An example of this is in the African ridge. So it will form a ridge. So there comes a time that this part of the Red Sea will be separated with one another because this area is moving away. So that is divergent plate movement. Then the last part is the transform plate movement or the transform boundary, also known as slipping or sliding. So the edges of two plates slide past each other in opposite direction. An example of this is the San Andreas Fault. So this is a transform plate boundary. So review tayo, we have three different types of plate movements. We have divergent, convergent, and transform. So when we say divergent, plates move away from each other. It is also known as spreading boundaries. Convergent boundary known as colliding boundaries. Two plates move toward each other, while transform is a plate movement wherein two plates slide past each other in opposite direction. So that is the different types of plate movements. Okay, so let us now discuss the volcanism away from plate boundary. So there are cases that volcanism does not occur along plate boundaries. So what mechanism can explain by this? So there was a nagging question with the plate tectonics theory. Most volcanoes are found above the subduction zone. So when we say subduction zone, one plate move over the other. That is subduction. Sinking process, that is subduction. So the denser plate or the denser structure or the denser crust will subduct or will sink over the other. So most volcanoes are found on the subduction zones, but some form far away from these plate boundaries. So how can this be explained? So this question was finally answered in 1963 by a Canadian geologist, John Tuso Wilson. So according to him, he proposed that volcanic island chains, such as in Hawaiian Islands, are created by fixed hotspots in the mantle. At those places, magma forces its way upward through the moving plate of the seafloor. As this plate move over the hotspot, since meron tayong location na hotspot, one volcanic island after another is formed. So Wilson explained, gave further support to plate tectonics. Today, the theory is almost universally accepted. So when this hotspot, when this plate move along the when the plate along this hotspot is moving, this will form a new volcanic island. So nakuha, ito, an example of this in Hawaii. When we say hotspot, these are locations on the earth which experiences longer periods of active volcanism. So these are fixed hotspot, but not all locations on the earth are considered a hotspot. So that is now hotspot. So it was explained by John Tuzo Wilson. Okay, so we are now on the last part of our topic, which is the convection current and slab pool. So these two forces or mechanisms explain why these plates are moving. So we have a lot of mechanisms explain this one, but we will just discuss these two. So convection current and slab pool. So first we have the convection currents. According to this theory, convection current occurs along the mantle, so which drags tectonic plates. So inside the earth, magma is heated near the core. So this is the core. Since this layer is made up of rock layers, so it is heated. So as this layer is heated, the rock now, this plume of mantle rock rises above the mantle since it is high in temperature, while the cool rocks sinks. So the hot rocks will now the hot rock will now rise, and the cool rocks will now sink. So how it is possible for the rock to flow? Over millions of years, the great heat and pressure in the mantle causes solid mantle rock to flow very slowly. So many geologists think that plumes of mantle rock rise slowly from the bottom of the mantle toward the top, since it is heated with 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 the extreme temperature in the outer core. So the hot rock will rise and eventually cools and sinks back through the mantle. Over and over, the cycle of rising and sinking takes place. So this causes the movement of the crust because of this convection current in the mantle. Nakuha? On the other hand, that is convection current class. So the convection current explains the movement of the rock flow, which causes the movement also of the plates along the Earth's crust. So as this rock is heated in the mantle, it rises. Then as it cools down, it sinks. And the cycle goes on and on, which causes the plate to move. So that is now convection current. On the other hand, slab pool uses the mechanism of the convection current. So when we say slab pool, so slab pool is the pulling force exerted by a cold, dense oceanic plate plunging in the mantle due to its own weight. So the theory is that because the oceanic plate is denser than the hotter mantle beneath it, this is in contrast in density causes the plate to sink into the mantle. So the process of a tectonic plate descending into the mantle is termed subduction. So in slab pool, they included the process of subduction, which caused the movement of the tectonic plate. So subduction pulls down the denser plates. So the denser plates is sinking. So that is slab pool. On the other hand, convection current is just continuous cycling of the rock flow. But on the other hand, it explained here that the denser the denser plate will sink over the other, causing the movement on top of the Earth's crust. So that is a slab pool. And that explains our topic about tectonic plates. So that's it. That's the end of the first chapter of our topic, which is plate tectonics. I hope that you will do your activity. The deadline will be on the Saturday.